So I'm Eduardo. I'm originally from Brazil. I've been here for almost 3 years, and mostly I work on the Confirmed app and also with the foundation team. So what you're gonna see today is like the combined work of foundation team and the other members that we try to condense. But small disclaimer: it is a lot of text because it's not like a super simple topic. So I'm not gonna read through everything, but you see a lot of text. So if you see something that you kind of don't understand, you can come back to the slides and send us a message. We can explain and so on. Okay, so the to start, so like super short thing about what is a modular architecture, why do we need it, what is a module, the things we do with interfaces versus implementation modules and how this affects the dependency graph. Also a disclaimer, this will be like super quick on this point because Rafa and George will come later and explain this in a little bit more detail. And then how we separate the modules, the layers, and how everything connects for us. So basically, a modular architecture is a Lego. Like the end goal is I want to be able to connect as simple as pieces of a Lego, should be super quick, and each piece should work alone by itself, like in a self-contained part. So why? Uh, so why is, if you have like a huge team, you need to be able to develop things faster. You need to be able to isolate the modules, the features you do. You also need to be able to scale super quickly. And you need some sort of support to collaborate better with the rest of your team. And so what is a module? The module for us, like you have one example here, and we have even a high number that's gonna grow soon. We're still modularizing some things. So basically a module will have these folders, 3 folders, and let's say an idea, a concept, a target. So the first folder will be sources, all the code, resources, JSON, image, whatever is not code. The tests that may or may not exist in a module depending on the type of the module. And those tests that will include unit, snapshot, integration, and so on. And also, sometimes we have sandbox apps. So let's say you have a small piece of the flow that you want to use in isolation. Let's say logging. You want to be able to say logging succeeded. You are able to go there and just pick that small piece, work whatever you need, instead of compiling the huge app, this 242 modules. You can just compile some of them, then it's super quick to do this change and check what's going on. So the first concept is, and again, reminder, we're going to talk more about concepts. So you're not going to see code, you're going to see folder structures, names, and ideas. Those ideas are not exactly what you see, like, if you look at clean, you're not going to see one by one what we do here. We have our interpretation on this to make sure it adapts to the reality we have in the project. So main purpose of a module that's an interface or a contract. When I say interface, it's not protocols. It's like the idea of a contract that will represent the module for the outside world. So the public APIs that shouldn't change that much. In this module, you'll see the contracts and models. And that's what you should be able to use everywhere. So, for example, analytics, you may have your own implementation of analytics, but to make your life a bit easier and help the compiler, which I will explain a bit later, instead of getting the whole like blob of analytics code, you get just the models and the method track event, for example, like super short things, super small things. And then every time you have an implementation, you will normally have the concrete, like the real materialization of that contract you're using on the other module. And this may go from, I don't know, anything like networking, the logging flows, the analytics core itself, like the whole thing that's going to make analytics work. And one important thing about this is that it's not going to be every time that you see a module that you should expect an interface. Some modules doesn't make sense to have an interface, especially because they shouldn't change much. So your dependency injection system, for example, it probably doesn't change much. So you don't exactly need to have the interface. You can, but it's not like a super hard requirement. And now, why? Why do you need those interfaces? So, in short, Xcode is not your best friend sometimes, and when it tries to cache something, or when there's a small change, it might compile everything instead of just a small piece of change you did. So, for example, let's say you have this dependencies, and you have the HTTP client, and all those features that directly connect to the HTTP client, they depend on it. So if you go there and change this module, there's a very high possibility that Xcode is gonna miss the cache and is gonna compile all this you see here. So it's not gonna be good in the end. So yeah. And of course you can say, but I use Twist, I use Buck, I use Bazel. It helps, but it's not enough. You need to do a bit of work on top of that to make it even better. So after you use these interface modules, your dependency graph will get way more horizontal, and you're not going to have like super direct dependencies. And in theory, if you don't change the interface, it shouldn't recompile. And the interface, the public interface, it shouldn't change that much. Of course, when it changes, you will recompile. But you shouldn't keep changing this. It's more common to change the core, the engine, what's behind that, than the interface. And this leads to way better, more optimized builds, and Xcode gets happy, caches better, your build system also gets better. This graph is actually something I just got from a presentation from Bruno Rocha. It's a guy that is from Spotify. I worked with him back in Brazil, and he's really good talking about this. So if you have, if you need more details about this, I think he's one of the best guys to go and talk about it. And also Rafa and George will explain our specific case on how this affected our builds and our build system in general. Yeah. Okay. So now we're going on the types of modules we have. So as we said, interface will be laying around most of those. So the first one is UI. And on the side here, you see the number of UI modules we have. You're going to see that some have the name like Adidas or Trilogy or no reference to a project. This is because we're still in the process of modularizing. So sometimes you're going to see those big blobs that should cover all cases, but they will be broken down. And a UI module, it can be super specific or super generic. Like when you have a generic UI module, it's going to have all UI related code, or most of the UI related code, for something that's more broad. Like let's say you have the extensions of UIKit, the extensions of Swift UI, or your own special flavor of doing view code, this type of things. So it doesn't have a very specific topic or domain. And then you have domain specific. So let's say you want to make your logging flows for different apps in a way that you just connect the dots. You could have a UI module that represents all the logging small pieces, like the input or the button that's very specific, so on. And then you import that in your logging experience that we're going to talk soon. and then you connect and you create the login itself. So for example, for China here, we could say that China uses the UI components, but not the flows. And then you can just piece things together. The next one is core. Core is like a super broad name. It's super common to say, this is the core, you put everything there, and that's it. But we try to separate a little bit. And we're still thinking if we should separate a bit more. But for now, we have two big groups just to understand the type. And normally, your core will be either foundational or essential. And that's something that's very, very close to the system. So the networking, the extensions to foundation, or your logging system, like things that are like very, very, very basic building blocks. And those will serve as building blocks for other cores, and so on. And the other types of cores we could have are domain, logical, or data sources. So you could say like you have four types instead of just two groups. And those will be where you start doing like the way to connect with backend, the way you do your algorithms, the way you do your business logic and flows sometimes. So for example, login domain core will be all the rules to logging, the repository, the use cases for logging, password checks, so on. User services would be like how you connect with the user services on the backend, the API. And the experience is the flow, what you see every day in the end. So all this piece together to make a kind of a small piece of the app, or even a mini app if you have a sandbox app. And they ideally should be super self-contained and super specific, unless we get to one of the examples we will have next. So then the example is we have more than one app, and then we need to think about scopes. Sometimes you have a module that should work for confirmed, adidas, China, retail, and so on. So you need to prepare for this. And how do we separate that? We say we have specific modules or a shared module. So when a module is shared, we think that every time you have two or more apps that might need that module, you should create it as shared. When you create it as shared, you have more things to think about. So for example, it needs to be stylable. The connection, the way you do navigation might not be exactly the same from app to app. So you need to have some sort of common contract between them. Those are things we are still on, like making it better and better. We didn't get to a final solution yet, but we will get there. And again, they should be self-contained. So ideally, every time you use a shared module, let's say you pass, I'm opening from app A, or I'm going to open with style A, and it should solve itself. Worst case, you get some callback, and then you handle this callback in your specific app. And the examples here are more on cores, but this also happens with any other type of module, UI and so on. And so if you see here on the folder structure, everything that's outside of a specific app is supposedly shared. And then the other case is app-specific. So app-specific is when you have like a super very specific environment to develop that module. So I'd say for confirmed, the analytics has some things on top of the base analytics. So we decided, okay, base analytics is a dependency, and then we specialize that. The deep linking structure, for example. We even had a presentation about this, how we saw that our deep linking was not super good. Then we tried to use the shared solution we had before, it was also not enough. Then we extended it a bit. We created this specific deep linking structure based on the other one, and then now we'll see if it needs to go up and become shared, if we need to refactor, and so on. So this idea of specific versus shared, it also helps us to experiment. So let's say I want to try something super completely different in confirmed. I can do it. And then if that works really well, I can go and say, hey guys, let's maybe use for everyone. That's how we do it. It moves up to shared. And also, as I said, on the shared one, you need to be very, very aware of the very generic things you need to do. When you have a app-specific one, you have the possibility of not handling those cases that the other app would need to handle. Of course, sometimes you may get to a point that, okay, you built this for app A, but now I want in app B, then we need to refactor. And how it all connects, so layers. Yeah, yeah, it's not much. We try to reduce to 4, or actually 3. So we have the presentation, the domain, the data, and integration is more like a concept. So the idea is that presentation should always consume domain, and data is always behind the domain. So first one, presentation. We have our legacy architectures, but the moment we started doing SwiftUI heavily, we tried a bit some other stuff, and we decided that TCA is a really good way to go. Of course, TCA has its own perks, own details, like we can discuss this for hours, but for us it's working super well. We don't do exactly the vanilla TCA you see, we do something on top, but it is working super well for us. So TCA composable architecture by 0.3. And one super good point, again, before starting the data, since we have all this isolation, these ideas that you should be completely self-contained, let's say tomorrow there's another soup of letters for architecture and you want to try, you do it in your own module, you connect with the rest, and then you say, okay, I proved that this is a better option, maybe we should start moving little by little. Then we have the data. So on the data layer, what we have is mostly data models, so codables everywhere, and API services. So how you go in the backend, you decode and you pass to the domain ideally. Or not just backend, sometimes other places. And there's a small delay. Yeah. The next one would be the domain. And on the domain is where the business rules will be. So whatever is like super close to the business, like how you do password strength, or how you do the logic like between getting from the backend, caching locally, and so on, that will be in the domain. So what we see on this domain layer, this domain box, is the use cases, which we try to represent as like super encapsulated functions. So you know that function that's not super nice to be like a big blob in your view model, you can encapsulate it as a use case. The workers are kind of not exactly the concept you see in VIP or Viper. It's just because if you start with use cases, there's a tendency to say use case A depends on B, that depends on C, and it's super messy. So we decided to call workers every time you have an entity, something that combines lots of things for more complex logic. So let's say if you need to combine 3, 4, 5 use cases to do something more complex, you're going to have a worker that may or may not just work as a proxy and connect the dots. And then it's a little bit easier to understand and not make a mess. You also have the domain models. So this can happen one by one. Domain models and repositories. I'm leaving logic controllers for last because there's a bit of detail on that. So repositories will be get from the backend, transform into a domain model, send it back. If you need to do caching, you also can do that there. And then the models, whatever comes out of the domain, it may be sometimes exactly the same, as what is coming from the backend, but maybe you just remove the codable. Or sometimes, let's say you are calling 3, 4, 5 services, you can have an aggregated data thing with these 3, 4, 5s and just share what is needed, not the whole thing. So kind of a middleware BFF in the app itself. Sometimes we need to do it. And then the logic controllers, which are basically a service. So whenever you have some sort of state, so let's say the example we are using lately, shopping bag, and you need to observe the changes on shopping bag. This is like kind of tricky because it's super close to the presentation. It's also very close to the domain. It's not exactly presentation logic. It's not purely domain logic. So we had to find a place to fit it. And we decided, okay, it's closer to the domain. It's more logical than presentation. So it's going to stay along with the use cases. And then integration. That's more like the idea of the glue code. So how do I connect all this? The main thing from all this is a dependency injection system. If you have lots of modules, there are ways to do it without it, but it's not super nice. So you need to have some sort of solution for that. Normally based on service locator. We use something based on service locator. We started using Swinject, and lately we have been moving to Swift dependencies from point 3. And then we have the option to have the scene assemblers. This is also like kind of a helper to bridge from the UI kit to Swift UI world. And the navigation service, which is something that we were using UI kit. We're now thinking about rebuilding it. So for now, it's still UI kit, but we have some ways to also use it in Swift UI. And the idea of experience entry point or a flow controller. So whenever you need to start an experience, you need to define how this starts, like register all routes, register deep linking, or maybe register the outputs they're gonna come out, and so on. And this may or may not be in its own place, like you could have a module for that, or you can just do it on the app itself, app delegate, go there, bootstrap. That's also possible. So how this all connects. So now we have all the boxes together. And in the end, the experiences are the big part of the thing. So you will use mostly your core UIs and external libraries, because every time we see one of those modules will probably be used by someone else. Like, for example, we have the running apps. We extract it out, and they turn into a library that's for internal use, normally using SPM. And then we also have some helpers like Twist, the build system, some specific configuration, and so on. So if you look how this all would be together, it's kind of like that. So you had this separation of all the small layers, how they will connect from one to another. Integration layer will be mostly kind of in the center because it needs to glue everything together. And then the other modules. As I said, we cannot do this with only Xcode. Xcode is good, but when you scale, it's not enough. So we have some helpers, let's say. We started with Xcode Gen, initially just to kind of break down the Xcode proj issues. And then we saw, yeah, this is not enough. We need something more robust. We need to have a better caching. So we started using Twist, which will be explained a bit later. Yeah. So now to finalize what we have been doing lately. So we built some things on top of Twist to really be able to express these concepts. So the most important part of all this is that the concepts will probably continue the same or change not much. And the way you implement them, that can change a lot. but the concept will stay the same. Like the layers should probably be the same, and the types of modules will probably be very similar. So we try to use twist to express that, extending twist to express that. So we have a catalog where you have the module close to the interface. You have the implementation interface, if it's a UI, if it's a core, if it's experience, and so on. We also introduced the internal modules. That's not a concept that exists in Twist. Twist just has frameworks and so on. There's also like a super nice extension to do the dependency graph evaluation, and that's one of the tools we use to check this among with other things to avoid the app to be super bad. We're working also on scaffolds, so it's not ready yet, but you should be able to say, hey, start a feature, and then you get all the scaffold. We have Danger and Sentinel. So we have Sentinel that's used for Danger. So it's a set of Danger rules that will also evaluate these architectural decisions and like keep the order, let's say. And we also have lots of sorcery templates to help on the day-to-day. And a good part of sorcery templates is that you can start maybe doing something just simply on the app, and then you can go and use for Twist. And yeah, that's it.
Are there any questions, ideas, comments? No, you are the first.
Okay. I only have 3 questions. Do modules have ownership? So say you want to change something in a module, but it's owned by another team. So are you not allowed to change it then? Or do you have to go through change requests and wait 1 month before some API is implemented in a core module? Or can you do it yourself? And then
yeah, so basically we work in a monorepo. So this is all on the monorepo structure. And for now, we don't have super specific rules because we try to talk to each other a lot. So we don't have a lot of blocks to change. What we do is like we try to be friends and say, hey, I'm going to change your module. Let's talk about it before changing. And then we try to reduce the friction. So we do pair programming and so on. So we didn't put rules. Yes, we need to add more rules, but it's working okay-ish so far.
How big is your iOS team?
Yeah.
How big? How many people?
From confirmed, we're now 6, and then for adidas is 10?
Okay.
Okay,
So
around 20 in total, plus the running apps that
I work
have
on.
15.
So that's,
Yeah.
Okay, so that's my second question is already answered. That's good. You say you used SPM. Really?
Just for the external, the standalone libraries.
Okay.
So we use SPM, like let's say, for example, we just implemented the login system that's going to work for all apps. So everyone just goes there, pulling. The design system is completely out of the repo. So we try to keep into the repo only what's closer to the business. When it starts to get super generic, super general use, we start trying to move out.
You always build with Twist, so you don't have the problem that Xcode has that thinks that it needs to rebuild every freaking time. Okay.
It still happens.
Yeah, thank you for your presentation. And my question is about the simulators. So one of the benefits of breaking into modules is you can start up the modules by itself. And how do you also like making sure that you can, like with each module, you can actually see the UI that's in the module? Like, do you have like demo apps for different like modules so you can like plug in the different, UI components? Or do you always make sure that you have previews for Swift UI code? Like, I'm just curious of like, how do you do that?
We're still working a bit on that because we were not able to make all the features as small apps. So we basically try to rely on these contracts. And so every time we have a module, we decide, okay, do we need to get the whole thing as a dependency, or do we need just the contract and mock it? For the UI, you just pull in the whole thing. And mostly, Rafa and George will show, you can even do that with Twist. Like you can scope into a specific part of the app with Twist, and then it kind of helps you from there. But it's also something that we're building on top. It's not 100% working, but it's getting there.
Okay, thanks for sharing.
It works well for the external libraries.
Hello. How many applications you have, and what is your build time?
Ooh, that question will come on the next talk. They will tell you a bit more in deep about this. But we have around, I think it's Rafa, George, help me. It's 5 or 6 on the monorepo. 5. Yeah. Yeah.
I think I saw a hand somewhere. No, there's okay.
In the same fashion, how long does it take to run your full test suite?
Sorry?
The full test suite.
It's part of the build time. So we didn't have tests before. We're getting more and more tests. Oh, also, Rafa and George will tell you more about this. Sorry.
Okay, thanks.
Yeah.
I think it's time for a little break. Visit the bathroom or get something to drink, and then we'll meet you at 8 o'clock.
Thank you.
Thank you, Eduardo.